Hey, welcome to the sixth episode of Distributed.NET Core course. It's Peter
Derek.
And today we'll focus on the internal HTTP communication, which, as you might remember, is like a sort of a problem that we mentioned in the last episode, where we actually hard-coded our internal communication between the API gateway and the discount service.
Yes. And I think that we should start with a problem that we actually we kind of discussed in the previous episodes. So basically, in some cases, it might be handy, and I would say that also necessary to fetch some data from one microservice to another. Because as you probably remember, we don't want to put, I would say, two large objects on a RabbitMQ in this particular case, mostly due to the performance issues that might occur. You need to remember that, of course, in most scenarios when we're playing with our application in the development environment, it seems that everything's working perfectly, but we need to be prepared for more loaded traffic, so we should avoid putting too large objects on a RabbitMQ. So we try to keep them as small as possible and pass the only information that's actually necessary for the another service to identify that something changed or was created or whatever. So we'll start with the very simple example of doing this, and later we will move further to the issue related to this hard-coded data in the app settings. So what's the plan for today?
Within our discount service, let's imagine that we would like to have some more sophisticated business logic when it comes to creating our discounts. For example, we would like to maybe analyze the already created or completed orders, whatever makes sense to you, and get these order details, this data, and maybe based or whatever it is, the customer, which might be some VIP or address or whatever it is, we would like to perform some logic, and based on the output, we could decide how big the discount should be, right? So some sort of like analytics based on the orders in order to generate any discounts.
So to make it clear, we will not implement any specific domain logic. We just want to show you our approach of dealing with larger objects. So maybe we should start with the order DTO to
or maybe with the event itself.
Oh yeah, okay.
Yeah, so here is the order service, and as you can see within our order service, we also have these messages, and we have a few events here. And one of the events is, for example, the order completed. So order completed happens once our order has been completed, meaning that it was created, there was enough products in stock, everything was accepted, and you paid for an order, given that we actually implemented the payment service, but we didn't, at least so far. Yeah. So this is when the order completed event happens within this handler for complete order handler living inside the order service. So it's being published here, as you can see. And now in our discount service, you want to subscribe to this order completed event. And based on the order data, we would like to maybe store it in our database and then perform some analytics and then create any discounts based on this order data. But there is an issue, as you can see, right? Only two properties.
Yeah.
Nothing else.
That's what I said. We try to keep them as small as possible, but we need way more data for our advanced calculating algorithm.
Yeah. So maybe let's start with a handler, and then we'll get into DTO. So the common story here, discount service, and then at first I need to define the message. So maybe let's do it here. Events, messages, events, and then order completed. And I can just copy and paste this one. So let's make it like this. And here it comes. I need to remember about this namespace, which is part of our routing key in RabbitMQ. So let's just say our message namespace is orders. because it comes from the order service. And that's pretty much it. Now I can take this type name and create a new handler. Let's make a subdirectory here called orders and new class called order completed handler, which will implement our iEvent handler, and pretty much the same story as before. Order completed event, implement the members, make it async, and here there will be some business logic. Let's make it just completed task for now. And yeah, here we like to fetch our order data, store in our database, and then later on when, for example, we invoke this create discount handler or some other process, we want to take these orders into consideration when we are creating a new discount, maybe in some automated way. That's the scenario that we're trying to resolve.
One more thing, we need to subscribe to this message.
Oh yeah, correct. So let's put it here. Subscribe event order completed. Yeah, and that's pretty much it. Now the question is how we can get this order data. And again, just like we did previously within our API, we could define maybe REST is or HTTP client and then just call our order service to get the data. But that would be hard coded, right?
First thing is I think that we should actually show the way how we can actually get this data, because now we got to the point where we have this event handler defined in the discount service. We have this event order completed, which gives us an ID of the newly created event. So we have necessary data for fetching this, and of course the whole writes to the application is done fully asynchronously. But in this case, we don't want to involve RabbitMQ and use RabbitMQ to fetch this additional data for discounts microservice. Instead, we want to synchronously ask for this data, and we'll simply use the API for this. But it will be not the API gateway, which is exposed and published for the end user, but simply we will use the same internal API as we do for the queries. So if we go to the orders and you see there is order controller, so this is basically the internal controller of this particular microservice. And as you see, we have this orders-order ID, which gives you an action result with the order details DTO. What we've given ID, this gives you a data about the customer itself, who actually completed the order, or maybe who actually owns this order, and a collection of the order items that are the part of this order. So this is basically the way we want to fetch this data using simply internal API. And now we get to this issue that Piotr mentioned.
Yeah, so let's start with actually defining our order details DTO. So within our discount service, we want to have either the same object or the project with maybe less properties, because as you might remember, since we are using JSON for internal communication, and it's pretty flexible mechanism for deserialization and serialization of the data, we can omit some fields. So at first, let's define our internal DTO. So just like we did for our customer DTO or for discount details DTO, which is our internal DTO, we can do the same for order. And I could say, let's create a new class and name it maybe order details DTO. And we can pick the fields that we are interested in, or sorry, the properties. So if we get back into our order details DTO in our order service, which is here, let's go into the base class. So I could, for example, copy all these fields, or maybe just subset of these fields, and let's put it back into our order details here. So there could be ID, there could be customer ID, items count, total amount, and so on and so on. But let's say that we want to have more properties. So maybe we are interested in customer, or maybe you are also interested in, sorry, not this one, in the order items. So maybe let's try to do the full the one-to-one mirror copy. And where is it? It's here. Okay, so I can take a look. What is my customer DTO? Okay, so this is the property, and again, I can take this class, and I can just define the same class on my own here, or I could reuse this class that I have here. So it's really it's really up to you.
Or maybe we can simply get rid of this customer. Maybe we don't need this.
Yeah, or maybe we can get rid of this customer, right? Maybe we don't need it.
Yeah.
Let's say that because we have customer internally, we can just maybe use only this customer ID to get the customer which is stored internally in our database, and maybe let's focus on this order items DTO. Yeah. So let's take a look at order item DTO. There is the DTO. Let's create a new class here. And let's do the same. So let's copy this one here. Okay. And finally, if we take a look at our details or the details definition, which is here, here is the collection of our order items. So that's pretty much it. Here is our DTO that will be fetched from the internal API of the order service. And yeah, now the original question, how do we actually get this data here? So what we could do, we could use REST-IS, and we could, again, hard code this configuration, or we could use HTTP client and hard code the configuration again, but we don't want to use it. Why?
that was awesome. But we don't want that. Yeah, the issue, of course, is that they hard-coded, even though that this is extracted to the app settings, and you can override this on your clouds or your servers, private servers, whatever you're actually using. There is still this issue that first since we're humans and we tend to do mistakes, we can simply do some small typo, and we'll have some issues with the connection to the remote microservice, to the other microservice. And of course, it's kind of annoying when you have you need to remember that this is a very small application, and it already has 9 microservices. In the more, I would say, enterprise scenario, you would end up with 50 or 60 microservices, and doing this manual configuration for all of them, both for the production and for the development, would be kind of annoying, and you would be very careful when it comes to putting these settings. And of course, when you will migrate from one environment to another, or maybe you would migrate to cloud, you still need to change these settings. And we want to avoid this. We want to, since we are, at least I am a very lazy developer, and to me the best solution is the one that actually involves me the least. Then if something can be done automatically by the microservice, not by me, then this is probably the best solution. So we want to basically do the following thing. We want to put this responsibility of registering the data to the microservices themselves. So once we start microservice, we want to make this particular microservice to register somehow to something that we'll discuss in a minute, saying that okay, I'm up and running, and this is the URL that actually works, and you can use this to communicate with me. Of course, we are talking about the host, about the DNS, or the host part of the URL that we're actually using. So in this case, it could be like localhost or something.
Yeah, so as you can see, this is how we could do it pretty easily. You could inject here HTTP client or HTTP client factory, and then just call, make an internal call, given that you know where your service lives, whether it's localhost, some IP, or some DNS, get the data based on its internal API, just read the content of the string and deserialize it, and you could get the data that way.
Yes, this is the level 1 of doing the configuration. So this is the hard-coded way, and this is the worst way. Why? Because in order to change the address of the host part of this URL, you need to actually recompile your application. You cannot do this. I don't think we can do this in other way. You simply need to change the source code, then recompile and deploy to your cloud or production environment, whatever. And the step 2 is what we actually did. So extracting these settings to app settings.json file. So we can override this without recompiling the whole application. So this is what we did. And it's, of course, way better than hard-coded values. Hard-coded values are in 99% bad.
Yeah.
And so yeah, this is the level 1, and we want to move it to another level. So level 2, which is service registration, or I would say automatical service registration. And for this particular case, we will use Consul. Which is
so maybe let's get back to the slide. So basically we'll use things called the tool called Consul, and this is one of the great tools which is open source and free to use, created by the HashiCorp, and they have a lot of other cool tools. We use at least one free additional tool. Sorry?
The Vault and
the Vault for sure, and maybe something else. We'll see. But they have very cool tools, and maybe let's quickly, you can talk about Consul since you made this slide. So this is the Consul, which is a service registration, centralized registry, right?
Yep. So basically, what we are going to do is we'll have, of course, each of the microservices will actually register to the Consul. So as you see, when we will actually, in a startup, we'll add some logic that says that whenever our microservice is starting up, we want to call Consul and register our microservice with the particular data. So as I said, on your development environment, it could be like, okay, hello Consul, I'm service A. And this is my URL. So this is I'm running on localhost, and I'm running on the port 5001. And I'm using HTTP, not HTTPS, because I'm running on the development. So this is my name. Let's say in this case, it will be like service A. So we have this key like service A. So using this key, we'll be able to get this particular data necessary for calling the service A. And of course, the same story happens to every microservice that actually registers to Consul. So then when we will hit, let's say, the API, and we would like to fetch some data from the service A, we won't use the hard-coded data saying like we will call localhost 5001 and then the endpoint. Instead, we will call Consul saying, hey, we need to fetch the data from the service A. This is the key. So in this case, this is once again service A, and Consul will return the instances that actually register as a service A with this data necessary for connecting. So that later we will use the data returned by the Consul to actually build the host part, and then to attach the endpoint and make the HTTP request.
There is one missing arrow, right? Because the last step would be to actually get this data, so we know where the service is, and then we ask the service for the data. And the important thing here is that if you have one instance, then maybe it doesn't matter. But if you have more than one instance, which is all about microservices as well, and you want to scale your app horizontally by adding more instances, which makes it more resilient, more responsive, and so on, then this key, which is called name in a Consul, you treat like a group. So for example, you will have here service A, and it can have 1 or 10 or 100 instances, and your API, while calling the service A, it will get the list of these services, and it can pick one of the services on the list and ask it for the data.
Yes.
And I think important thing to mention here is that the console works in a sort of randomized way. So if you take a look at this, at the documentation of the console, you can see here, as I described, that whenever your application calls the console registry for the DNS, it will receive this randomized round-robin response, right? So in a console, you will have a list of the instances that are up and running. They're available, for example, to process your call, and you will get the randomized list of these instances. So you can, for example, just call first of default using link, and just hit the service to get the data. That's by default how the console works.
Yeah.
Okay, so maybe let's write the code for a console. So this was level 1 and level 0 or first step and a second step, and now we are getting into this more automated, like the better step, I would say, where the responsibility of keeping track of living services and their internal communication, their configuration, their IP addresses and so on is not like a concern of our microservice, is a concern of the service registry. So at first, let's start a console, and here you can find in this DShop compose the file that can start the console. And we made this Docker compose file to also start a vault. We'll talk about vault, which is the centralized credential storage in one of the later episodes. But you can start this one and just use console without vault. So just type Docker compose, and as you can see, we can do -f docker compose console vault, and maybe let's start it without -d in a mode that it's detached.
We want to show the diagnosis, diagnostic information.
Yeah, so we have Redis, Mongo, and Rabbit up and running, which is our infrastructure, and we can just run this console vault. I need to put the up.
Yeah.
Right, and the up. Okay, so it should start our console and vault, and the console will be available under this 8500 URL. So 8500, and here is our console. And as you can see, there is only a single living instance. There's a console itself. I can click into console. As you can see, if I were to actually create a high availability console cluster, I could see there, these different DCs and multiple instances of console. But if I take a look into this node, it's only the single instance of my console, which is enough for this development mode. So that's where I will register my services under this particular name. So here is the IP address, the port, some ID, and the name itself. And now let's try to register our app into the console. And there is a .NET Core library for integrating with console. And as you might imagine, we also made this easier, and we added our own code to make this integration easier. So getting back to our startup class, we can do the following. At first, I need to register all of the interfaces within our IoT container. So I could just type anywhere here something like builder and add console. Is it right? Console, or maybe it was services. Let's meet. Oh, it was already here. No, sorry, it's order service. Should be startup discount service. Okay. Oh, yeah. So here I can type, for example, services and add console like this. And if you take a look, again, extension method that just registers here some classes, some options that we bound from our app settings, and so on and so on. So here is our IOC part. And now the more interesting stuff, which is actually making use of console. So anywhere in my configure, I can just say app use console, and just keep in mind, console is not a middleware really. So we just tend to use this convention app use, but like with RabbitMQ, but it's not really the middleware, so the order doesn't really matter here. So I can type use console like this. And basically, if I start on my application, then it would register to the console, given that I actually set up, not this one, that I defined my application settings for the console here, which we'll do in a minute. But there is one very important concept about console, because once you register to your console, it needs to keep, track. It needs to keep track of your actual instance, right? So whether you are available or not. So what would happen if my if my application went down, right? What would happen? Now, it would be still visible here, and it will be a dead instance. So we can do two things in order to prevent this from happening. And the first thing that we can do is to actually, I don't know if it's a valid word, but at least that's the name of the method, to deregister ourselves, to remove ourselves once our application becomes offline. Just so that it will be removed from this service registry. It will be no longer visible here as an available instance. So as you can see in this use console, which is of course another extension method, and here we have this very simple strategy. Yeah, it's here, unique ID. And we just made this simple interface called iService ID, and by default, it will return your application ID as a new GUID. But you can provide any strategy here as you want, maybe part name of your machine, MAC address, whatever it is. So we'll create a new ID, unique ID for our console, so for our microservice instance that will be registered in a console using this simple strategy. And my use console invocation will return this ID. As you can see below, it will just return this service ID, which is this unique ID being GUID. And I can type the following. Service ID.
Yes, just to make it clear, because maybe this is kind of confusing. So as we told, the name itself is used for the grouping.
Name is a group, right?
Or this could be a key, but assuming that you have only one instance up and running and connected to the console, because then you can simply use the name as a key in this case, and you would only get one instance back from the console registry. But now, assuming that we'll have, and this is probably what we tend to do, so assuming that we'll have more than one instance for one particular microservice, we need to kind of distinguish between them. So since each microservice will have the same name, because for instance this will be the discounts service, we need to distinguish between the instances. So for this case, we will need additional parameter, and this is the service ID. So basically, as Piotr said, in this using this implementation, this will simply create new GUID for each instance. So then you would simply receive, like, if you would ask for discount service, and this will be the grouping key, let's say, this will return you all instances, let's say 10 instances, and each of them would have a different GUID for this service ID.
Yeah, and actually, sorry for the mistake, it's actually service name and ID, but you get the idea. ID is unique, name is the group, which is common for the family of the particular microservice. Okay, and now the question is how can I deregister myself? And just, if you don't know how to do something, you can, for example, look into other services. And as you can see here, we have this iConsole client, which actually comes from this library. So we are using the .NET Core library for the console, and here lives this iConsole client, which is actually part of this library. And by using this iConsole client, we can talk to our console API, because console, as other tools created by HashiCorp, has internal CLI. So you could basically type in the console CLI and perform all of these registrations, the registrations, and so on. So here I could inject my iConsole client, and then, just like we did before for our container dispose, we can say console client dot agent, and now we have this method called service deregister, which takes our service ID, which is this one. So if our application becomes offline, it will remove itself from the console, right?
Yes.
So this is the whole magic, and that's pretty much it.
I think that's clear.
Yeah. So now let's try to start it. But before we do it, we need to configure our console for the service. So we need to add the proper section for the settings.
Now we can copy paste.
So let's just copy paste. We have this section called console, and here let's copy it from the order service. I'll just copy this whole stuff. We'll get into details later on. So the important part for now is this one. Enabled, I will make it true. and URL of the console, which is localhost 8500. Name of my service, which is the name, which will be group of the service. I'll call discount service. And for now, let's keep it like this. Let's make it localhost for now. We'll get into this later on. And our port will be 5010. But this is also for the next case. So let's try to start our app now and see if it will work. So we'll get into our service. Let's see. We can open our discount service and start it.
And that silence.
All right, so it's up and running. And let's see, if I refresh my console UI, you can see that it's here, right? So it registers itself under discount service, which is the name, which is this group. And here, as you can see, there is the address, localhost, and 5010. And here's the unique ID, right? So this is our discount service and this random GUID. And I can get here and I can see that it's alive. And now if I get back here and if I kill my app, just Control C, which is a graceful shutdown, let's refresh it. And it's gone. Okay? So it's no longer here, it's no longer available, which is fine. But there is one issue with this, right? Which is which will not always work. Because sometimes the graceful shutdown might not be an option. Your app might just die. And it will never get into this point, right? Into this one.
Yeah.
So we can resolve this. And we can do it by built-in health checks that are part of the console as well. So again, if you take a look into this extension method, you can see here that within this registration, you can also provide, we have this flag here called ping enabled, which is actually a health check. And I can register this agent service check given the interval, let's say 5 seconds, 10 seconds, 1 second, whatever makes sense to you. And here I can say, for example, every 10 seconds, I want to ping my API under this specific URL, the ping endpoint, which can be /ping maybe, or /healthy, or you can use ISP.NET Core health checks, whatever. And if it doesn't respond, if my endpoint doesn't respond for example, 5 seconds, it means that there is something wrong with my app, and I should remove it. Okay, yes. So I will just remove it from console.
And I'm not quite sure, but I think that for console, it's actually for the checking this health checks. This is it doesn't matter whether this app will actually return successful status code. I think that
I think it doesn't matter.
Yeah. So if this if you would try to ping something that is actually protected and it would return the 401 or 403, I think that this would still work, because for console this is clearly signed that your API is up and running. But I'm not quite sure.
It could be. Okay. And
so maybe can you just go to the app setting JSON to show this
exactly.
Part?
And I can just say ping enabled to true, but there is one catch here, and the catch is this address. Now remember that we are running our console through the Docker, right? And for the Docker, thing called localhost is actually the console is the localhost on its own, right? It doesn't know what is the localhost unless you use, for example, the Docker on Linux and you started with this host parameter that will bind this Docker address into your localhost. Then it will work. But if you're using Windows or Mac, you can do the following. I can type host docker internal and like this, and then it will be able to just call my my service by resolving this URL, this DNS, and calling my port 5010.
Yes.
This is the only thing. But remember, if you actually deploy your app somewhere and use some service, maybe like Kubernetes and so on, then it's really not an issue because you would use some namespace maybe for your external load balancer or some Kubernetes namespace. But for this scenario, if you are running in a local host and we are using Docker here, you need to keep in mind that otherwise it will not be able to talk to your service internally.
Yeah, if you have an experience with the Docker, then you should know this.
Yeah, but there's always this tricky thing. If you're running it on Linux, Mac, or Windows, there are different URLs, so you have to keep it in mind. So let's run our service once again, and we should be able to see now two checks that will be performed for our service. Okay, so let's refresh. And it should be green in a moment. So let's see. Right now it says discount service failed, but it should be working in a moment once the ping is ready. At least it worked before. So let's see. Services. Okay, discount service. Oh, let me check if I actually have my ping endpoint available, because it might not be available, which would make sense. Yeah, so my ping endpoint is not defined, as I can see. So this is why it's not working. So I think I need to define it. Let me just quickly check what was the name, because we have so many extensions that sometimes we we get lost. So let's see, where was our ping endpoints? I think we need to use this service ID. Let's see, is it this one? No, this is just the ID. It's not this one. Or it was authentication. Let me just check what's the name of this middleware. Let's see if I can. Okay.
You lost it? No?
Yeah, I don't remember where was it actually stored. Let's see. But yeah, so as you can see, the console is trying to ping our our endpoint, but it's not available. I think it could be the part of the app metrics actually. So let's try to make it. Let's just make it. Yeah.
Maybe just implement this in the,
Yeah, I think it's part of the app metrics. So maybe let's just do it like this. Let's just make it simpler. Let's just make a console call our API without any.
Or maybe
base endpoint.
Maybe we can change this to ping as it was and simply add that method in the controller that will do nothing, and we could.
Okay, we can also do it. It makes sense.
Because that way we could put the breakpoint there and show you that this actually pings this. Something happens.
Okay, it makes sense. Yeah, I'm pretty sure that it was part of the app metrics library, which is not being used here, so this is why it didn't work. But that's good to know. All right, let's make it an HTTP GET.
So
it was finally the failure that everyone's been waiting for.
That's what I wanted to say.
Okay, let me kill this service. Let's see if it's actually removed. Okay, cool, it was removed. So let's run it once again. And here is the ping. Should work now.
Okay.
I hope it's running the discounts. Okay.
Yeah. Jesus.
Yeah, the first time you run the app, it always takes some time.
Yeah.
Okay. So it should be back here. And now as you can see, here is the ping. And let's see. Our console, it should be green in a moment. So it's hitting the ping again and again and again. And let's get back here. And it's, finally it's green. So if I go into this service details, you can see that there will be two checks. One is this first check when you register the app, and here is the ping below. So it's pinging every few seconds, and if the ping doesn't, if the ping would fail, then it will deregister or remove the instance of the service. And this is how you deal with it. Okay.
So we can leave it as it is, because for now
Yeah, we just need to remember to remove it once we start using the metrics later on, because otherwise there'll be another failure. Okay, so this is how we can how the console works in under the hood. Now the question is how we can use console in order to talk to our service. So each of the app settings has this console defined. So we could simply make this just say it's available for the other services as well, and then the services will be visible here, right within our console. So right now, whenever I want to make a call, I will not be calling localhost whatever it is, and I will just call discount service, order service slash API, and get the data that I'm interested in. So for starters, I think we can use our console HTTP client. So I could inject it here. So let's just inject my console HTTP client.
And this is not the part of the console library itself.
Yeah.
So this is something that lives within the common package.
Yeah. So it's very simple HTTP. Like under hood, it uses HTTP client. So it will try to get the data from the request URI. But there is one important thing here. If you take a look here at extensions, it registers this HTTP client using this interface, and it also defines this message handler. So this is where all of the magic happens within this message handler, which is a little bit more complicated. So in this message handler, I have this interface called iConsole Service Registry, which is very, very actually simple. So in this service, I'm just calling get async. And I'm just calling here, as you can see, I'm using this iConsole client and I'm invoking these services. So it will return all of the services that are available, and then I can, either just do first or default because it's randomized at least, or I can do my very naive own implementation of the random here. So whatever actually makes sense to me. But this is where
maybe we can just create this, make the use of this console client, and we'll simply make a call and discuss each step. Will be much easier.
Okay.
To go from step.
So this is where this magic happens in this message handler. This is where we talk to console and just grab the instances. So maybe put a breakpoint here as well.
Yeah.
Okay, and let's get back into but before we do it, we'll need to start all the services, right? Because we'll have to go through this order completed scenario, which will
yeah,
which can be
or you can simply, if you have some order already created, you could
no, I don't
message.
I have an empty database, unfortunately, so
that sucks.
Yeah, but okay, let's give it a try. So I will inject it here, and then I can say just this DTO equals my console HTTP client and get async. I want to get the order details DTO, and I will call the order service and its internal API, which is this one, like this and that.
Yeah.
And there will be my order DTO below. So let's do it maybe like this. So let's put a breakpoint here and here. Yeah, but before we started, we need to go through this scenario. So
and you also
yep
need to enable registration on the orders.
That's correct. So yeah, let's add this registration for the order service.
Yeah,
so here I can
for now we don't need the other services involved.
Exactly. And yeah, we can also enable the ping here.
Yeah.
5005. Okay, but we need to start quite a few services.
Yeah.
So let's go.
I must say I really enjoyed this episode because this is the first time that actually something more advanced happens. So
yeah, we'll see.
Yeah, if you waited for this and you already have no clue what's happening,
Sorry.
This is a good sign.
Yeah. So at first we'll start the API, and we have to start pretty much all the services. I think also including the operation service. So identity, because for the order completed, we have some
operations don't need to be resolved, I believe.
Yeah, because we also have some distributed logic for the order completed event. So All right, so API, identity, customers.
Discounts and orders.
Okay. Customers. And products as well, because we have no products.
Yeah.
And then the operations, and then the orders, and then the discounts. So
I think that from the next episode we actually need to start using this .NET Run All. This will be easier.
yeah, but I just wanted to
we
mention
already use
that there is quite a few things to start.
Yeah, because
And
it's
finally,
getting bigger and bigger.
Yeah, so let's see. API, customers, identity, products, operations, orders, and there will be the discounts finally. So let's see. Okay, let's open.
Do we need operations?
Yeah, we need for the completed order event, because there is some logic. All right, so here is our order service operations. Yeah, actually it seems that it had the console name, but this is what matters, order service for now. And finally we can start our discount service. So let's just put okay, we have breakpoint here, so let's run it. And I hope it will succeed. Okay, so we need to go through this flow. So if I open my DShop REST, and since I have no data at all, as you can see, my database is empty. There's nothing here. We need to start from the very beginning. At first, I will create an admin. Okay, I think it should make a request. Let's see. Yeah, I think. I'm not sure. Let's see. I think it did. Oh yeah, the first. Oh, it didn't start yet. Okay, so here is the user, and there is the sign in. So here is the token for our admin, and now let's create a new product. So I'll paste a token here, and let's create a new product. Okay, so it should have the product. And we can actually call localhost 5000/products, and there should be a products with one product in a moment at least.
Oh.
No,
you typed the wrong URL.
No, that's okay.
Okay.
All right, so we have a single product. Now I can get back here, and let's create a new customer. So again, I will sign up as a customer. Yeah, sign in. There is an E missing, so E and this one, and now create a customer. All right, so let's take a look if we have the customer data in our discount service. Okay, so so far everything seems to be okay, and we should also have the products within our. No, we don't need to have it here. So I think it looks good so far. Yeah. Let's try to create a new order. So at first I need to add a product to my item. So I can call this discounts product service, grab the ID, and I can put it either here into my variable or just paste it here. It'll be faster this way. So let's send a request to my cart. Let's see what happened. So I can grab my cart by calling the get cart. Let's see. Okay, here is my cart with single product. And now I can finally call post orders, create a new order. All right, so there should be a new order. Let's see, refresh. There is a new order. Yeah. And the final step, I will get this order ID, which is this one. And I will try to complete an order, which should produce our event. So let's just paste it here and make a call to orders complete. And now let's see, let's wait. It should publish the event, at least after a while. Let's see if it worked at all. It's completed. but somehow we didn't get this event. The question is, did I actually? Oh, I think I didn't start it. Or no, I started it. So the question is why we didn't get this data here. Right, let's see. I think I know where the issue is, and I think the issue is, yeah, I'm pretty sure what the issue is. So let's get into our extensions for the console. Yeah, and I think the issue is here, because here I registered the console client as interface, but I injected it as the class.
Oh,
yeah,
Jesus Christ.
but I remember one thing about this one. I remember that when I tried to inject my console client as interface, I got somehow it couldn't be resolved by the container. I don't know why. So let's just do this quick fix for now. Let's just try to do it like this as a class, because yeah, like I said, I'm pretty sure that I had some issue with this registration here, and I couldn't inject it as an interface. So let's just do it like this, and it should work. I'm pretty sure that there was a reason, because it works just fine if you do it at HTTP client interface class, but for some weird reason, I couldn't get this to work.
So we should start with the you see, we should start with the subscribe event extension. Yeah.
Okay.
There was
yeah, but this
hopefully this will.
No, I'm certain this will work. Okay. So I can hit my complete order now, and it should work just fine. So here is my order ID, and that's it.
So yeah, this is how you make longer videos on the YouTube. Yeah, simply make a bug and struggle with this for 15 minutes.
Did I change it? Did I change it back to the class, or didn't I? Oh, here we are. No, sorry, we are here. Yeah, we hit it. Okay, cool. We are in the handler, I think. So here it is. And we should actually hit our endpoint. Where is it? Order completed. Which leaves...
in discounts.
In discounts, which is here. Okay, F5. We are here.
Yeah, so we had...
Finally.
Typical dependency injection issues with the registration.
Yeah. So order DTO, and yeah, let's get into our Consul Fabio client. So we can get into this class, and let's put a breakpoint maybe somewhere here and here. Yeah. So before we did it, it actually called our message handler. So it was here before. Then it called this service registry to get the list of instances. And finally, F5 should get the data itself. So let's wait. I hit F5. Okay, let's take a look at our Fabio. Order service should be here. It's here. Host Docker internal 505. I think I know what the issue might be. Isn't it that we are actually trying to call, because it registers itself under this Docker URL, and right now our service got this Docker URL and is trying to call this one instead of the local host.
Oh yeah.
So there's this mismatch, I guess.
Okay, yeah. So basically, right now the services, I mean the microservices, not the console itself, are running simply using .NET CLI. They're not put inside the Docker containers, and we had this host Docker internal for DNS for actually.
Yeah.
Yeah.
So yeah, and this is something that you need to keep in mind when you're trying to develop everything locally while using the Docker. So right now we set to our console that we are able, then it can reach us under this URL, which is valid for Docker. But if we try to get this from our my discount service, it will not work, right? Because this is valid for Docker. But I think, could we use this Docker for Mac localhost here? I'm not sure if it's going to work or not. So maybe let's try to do it like this without a ping, just to make sure it works. But I think maybe this magic URL could also work here. Docker for Mac localhost.
I think that this should work.
Okay, we
can just leave it as
let's just try it with localhost without the ping. Yeah, so as you can see, quite a few obstacles.
Yeah. So to make it clear, for ping enabled, we kind of had to do this because Consul is running in the Docker container, and for Consul itself, the local host lives within this container, and our microservices run as a simple .NET instances without the Docker, are beyond its scope. So we use this magic Docker host internal for the Consul to allow him to actually ping our service. But if we will disable this, we can simply get back to the local host to actually make it work without the Docker. So services will be available under localhost and then some port instead of this weird Docker host internal.
Exactly. So let's see. I think this is final third try.
Yeah.
But I think this magic URL for this Docker for Mac localhost should also work. So we can try it later on. All right. So final one. Create a new order. And
but I would say that this is what happens when you actually you have some mix. So some services are running on the Docker, some are not. This is typical thing. Actually,
Okay. So here we're getting into our message handler, and let's see. I will click F5. All right. So it takes our server registry, and now let's put a breakpoint here into the send async. Now let's see what will happen here. F5. Now we are getting here again, and it will try to get our URI. So as you can see, there is this order service. So what will happen? Let's get into this get URI, and let's put the breakpoint here. It will try to resolve this based on a service name. So it will get the service name, and let's see. Our service name is the order service, as you can see.
Yeah.
And next step, send async. So if you get here, you can see that we are using poly here for the retry. So we'll try, for example, to send it 3 times. So
we'll get to the poly and the
but this is just so you're not scared about this method. And finally, get request URI async. Okay, so let's put a breakpoint here and here and here. So here we'll try to call our service registry. So again, let's dive deeper and put a breakpoint here and here. So it will call our agent to get all the services, and we'll look for the services. Let's see, we got the one service for this type. So as you can see, it's lives on a local host. It's order service ID, and this is under the service group called order service. Okay, let's click F5, and finally we have a new URI, which is translated into our local host. And now we can finally get our data. All right, so here is the response, JSON convert, and there is our DTO. Wow.
That was
that was
quite,
interesting.
Yeah. So
okay.
Once again, I think that we should sum up what actually happened once again, just to be clear. So basically, we completed an order, and an event order completed was published and was then called by discount service inside, and then of course processed by the event handler that we created in this episode. So then we use this Consul HTTP client for getting the order DTO from the order service. So we use this order service as a host part, which was used as a key for the Consul using this order service key, we got the list of the instances. For this particular case, we got just one instance, and within this instance, we got necessary metadata. So we got the local host and the part with the port. So we got the local host and the 5005 or something. Yeah, I believe.
Yeah.
So we use this data to actually construct the host part of the URL, and the rest was, of course, the same. So there was the orders and dash ID. So Consul provided this, expected this key, received, and returned the list of the services. And of course, that was if you want to see how this is actually implemented, because this might look scary. The whole mechanism is pretty simple, but just we encourage you to visit our GitHub and go to the common part, and there is a whole section inside this common package dedicated to the console itself, so you can go and see how this is actually implemented. So might look scary, but it's not.
Yeah, and let me just try one last thing. So as I mentioned, at least for the local development of Docker, if you are using Windows, you can put here Win. If you are using Mac, you can use here Mac. And there's this magic URL, Docker for Mac or Docker for Win localhost. And if I type into my browser, I can access my localhost sort of through Docker, right? So I can just do Docker for my localhost 5000, and here's my API. So let's try to put it here as our address part. And let's do it for discount service, and let's do it for order service. And let's just see if it will actually work with pings, and it will work with our service registry, okay? This last thing because we'll need pings for the next feature anyways. So let's just quickly restart the order service and restart the discount service and see if it works. So there's this magic URL that you can use if you are using Docker on your Mac or Windows. And if you're running on the Linux, you can simply type localhost here, just the localhost. But then you just need to start Docker with this attribute, which is --net equals host, which will bind your Docker into your localhost. Okay, so let's start it once again. Here is the order service, so discount service, and as you can see, there was some message in the queue that wasn't processed before. So let's go again, order DTO, and let's try to get our URI. And it should now use this Docker for Mac localhost internal address. So let's do F5 again, and service name, and let's see, it should get the services again. Okay, here is the services. This is our Docker for Mac localhost. Yeah, one instance, and let's see if it will work. It should work just fine. F5. Oh my god, I think it was another another event that wasn't processed before. There were a few events. So as you can see, even if our app is down for some time, once you start it once again, there will be messages waiting for it in the queue. Where was it? I think it was. It was processed somehow. I'm not sure if I have a breakpoint here. Oh, the last one. Okay. Maybe
basically.
I think I removed this.
Yeah.
Why it's still there?
Is this now? Yeah.
Yeah, I'll just do it like this, which will be much faster. Sorry, not an empty cart. Cart, get, post. And finally, oh, so many. Oh, come on, F5. And finally, my complete order, which is here. So last order. Okay, let's send a request. Okay, here. Okay, and device, there is some issue. Okay, so as you can see, it's trying to get the data. Let's see if it's there. Oh, it works. It's here, which looks fine. So it was able to fetch data, sending request. But somehow, it seems like somehow our endpoint didn't hit it. Didn't hit this breakpoint. Sorry, we didn't hit this endpoint somehow. But as you can see, it actually sent the request to this URL, which is valid because I can open it in my browser, which is here, right? So yeah, somehow we didn't hit the breakpoint. And why did it hit? Yeah, there is some. Somehow we didn't hit it. I'm not sure why. Device that configures socket exception.
I have no clue. There's too much services I see. Now I'm kinda lost.
Yeah, but again, it's sending the messages, but somehow it couldn't get the data. We'll probably have to debug it. But anyways, this is how you can use this magic URL to get it. Yeah. Okay, so the last thing that we can use, right? Like a level 3, I think.
Yeah. So basically, because this looks like a kind of complete solution for us, because if you think about this, we have this registry that we can simply query for the particular instances of the certain, within the certain key. And actually the console itself is something that we call the server service discovery, right? So basically the server itself, so in this case the console, is responsible for giving this giving us the instances of the particular service, and this randomized using this, it load balances this traffic using this randomized round robin. But we can go one step further and actually involve the another tool for load balancing. So and as you see, this is also suggested in the HashiCorp documentation. So we can use the Fabio, and the Fabio itself I think that was created for the eBay, and now eBay. It got open sourced. So basically, this is a very simple load balancer that actually creates a routing table, and it integrates very easily with the console. So maybe we can get back to the slides to actually, to see how this is how it's working, because this is quite simple mechanism itself. Yeah. So
let's get to the actual slide. This is like what Fabio is, right?
Yeah.
And there's how it works.
Yeah. So basically, the Fabio is this is the one with this blue. Yeah. This is the Fabio. So basically, what it does, it's, as you see, we start with the typical console registration. So in this case, we have the service A that actually registers as a service A with, of course, with this additional service ID. And we say that we want to register ourselves as the localhost 5002, but also we can provide to the console some custom headers. And these headers will be used as further for the Fabio integration. So we will say that our service A supports these two paths. So if we will send a request under API/values or API/users or whatever actually you have in your particular microservice, then you can these two paths are the one that we actually can handle somehow. So then console sends this to the Fabio. Maybe Fabio fetches this from the console. So it creates this routing table saying that whenever we have some request that goes to API values, we can forward this to the localhost 5002, so to the service A, because it claimed that this actually it can handle this somehow. And the same goes to the API-users. So this can also be forwarded to localhost 5002. So then, if we will do an API call, we will always do API call to the Fabio, so as our load balancer. So Fabio is available under 9999 port, I think.
Correct.
So I would say that technically we could hard code this, because this will never change. So we'll actually do something like localhost then 9999 API users, and then Fabio, using this routing table, would say, okay, so you want to fetch some data from the API users. I have some service that actually subscribed with this endpoint, and this is the localhost 5002. So then Fabio would simply forward this to 5002-API.users to make this HTTP request, and then get the response and forward this to the caller. So basically, this is how Fabio integrates with the console. It's a very simple mechanism, and you will see in just a minute how this actually looks. And one more thing, I think that we should say about these strategies in the Fabio. So by default, this the Fabio, you have this.
It's open here.
Yeah. So basically, by default, Fabio uses this pseudo-random distribution, and as you see in the docs, as far as we understand this simply creates a seed for the random using this microsecond fraction of the request time. And by doing this, we can actually resolve the next instance that will actually hit within the same key. But of course, we can change this, providing the proper environment variable, and we can change this to the round-robin distribution.
Yeah, which is also pretty simple.
Yeah.
So,
but it's still better than the pseudo-random. So I'm
not sure if it's better or not. I think, we'll have to take a look which one is better. Just keep in mind that it's not really sophisticated, and both are very simple load balancing mechanisms. If you want something maybe more sophisticated, you can look for another tools. Like one of the newer tools is called Traffic. And for example, with Traffic, what you can achieve is this weighted round robin or dynamic round robin. And there are also other, load balancers that, take into consideration things like latency. So they measure the latency of the request, and based on this latency, they will return to you the list of instances that has the best latency, and so on and so on. So there are different load balancing strategies, and for the Fabio, we have these two strategies which are quite simple, but sometimes it might be enough. Really depends what you want to do. Okay, so let's get started. And again, we can start the Fabio through our Docker. So if you take a look at this compose, here is the single compose file for the Fabio. And here is this what you mentioned. So by using this Fabio proxy strategy environment variable, I can either say RR or RND. By default, it's RND as far as I know. And the other important thing is to notice that we need to be in the same network. If you are using the Docker, we need to be in the same network where our console lives, because it's using the console, right, to work, to create this routing table and to get these instances. Okay, so as you can see, it will expose two ports. So let's start the Fabio. And
one is for the load balancer, and the 9.8 is for the UI. So you will actually see this routing table in action.
And maybe let's just kill everything. And okay, so here's our console, and now I can do the same for Fabio. And here is the Docker compose Fabio, and let's make it up. It will start quickly. And now I can access the localhost 9998, where you can see the routing table. And for now, there is no services registered.
Yeah.
Okay, so let's take a look. For example, if we take a look at our order service, which is here, here is this registration for the console, and here is the registration for the Fabio. So I can type enabled true, right? And let's try to actually start the Fabio service. Sorry, start the order service and see if it works with the Fabio. So let me just restart it.
Yep.
Okay, so I should be able to refresh this now, and I should see there is a routing table for my order service. Hopefully, let's see. Okay, here is my routing table for order service. So what I can do now, I can do something like localhost, and remember 9998 is for this simple UI, and I can do localhost 9999, and then based on my service name, which is the tag. So as you can see here, there is my service name, the tag that I'm using, the prefix. I can do /order service, and let's see. I will get the response from my order service, as you can see, and I can do something like /orders, and it will return to me the list of orders, which would also require to pass the customer ID in order to get the orders for the particular customer. So as you can see, I could pretty much use the HTTP client and just make a base URL to hit the Fabio at all times and just use this URL, because Fabio will be aware of our instances, and based on the service name, which is this part, it will just redirect traffic to this particular instance based on this simple load balancing strategy.
Can you go also to the console, because I think that the console actually shows the
that's correct.
Custom header.
Let's see. So yeah, there is the header that we need to use, this URL prefix, and then a strip. So if you were wondering where does it came from, again, extensions for our Fabio, for our console, because it's also here, and down below we have this Fabio tag, which is here. Get Fabio tags, and I just use my service name, and that's it. And I just create this prefix here. So I have these Fabio tags, and as you can see, I use it here. So if I said that my Fabio is enabled in my app settings, it will just add these tags and register it into my console, and then the Fabio will create a routing table, and I can hit my Fabio in order to get the data. So right now I could just do this, and in my, for example, order completed handler, if we get back into our discount service, which is handler, which is here, I could pretty much do this one and then just change it to localhost 99999 and make it like orders-service/orders. And that's all. I don't need to use this console HTTP client. I can do a very simple interface for my, let's say, Fabio HTTP client, and that has hard-coded base URL of the Fabio or the URL that is taken from the app settings, and that's it. That's how we can make our life even simpler.
Yes.
That's the whole magic. And the last step, the rest is, right?
Yes, because of course we can, as you see, we kind of have three ways of configuring this HTTP client for us, because we can either use the thing that we did in the last episode, so we can use just the resties for doing the simple HTTP calls, or we can involve the console as our service discovery. And the last option is using the Fabio with the console to have this console and the load balancing provided by the Fabio. So of course this is the stuff that that you actually need to program somehow. So we put this into one extension. So changing just one flag, and of course assuming that you actually enable the Fabio and the Consul on each particular microservice, is so basically choosing the strategy is dependent on just one flag. So if you go to the API, I believe.
Yeah, let's make it into our API gateway, right? So here, right, the API gateway.
Yeah.
And remember, just one thing. We don't need to enable the Fabio we don't need to enable the Consul for API gateway, because API gateway only need to know maybe about Fabio, right?
Yes. We don't need to register.
So it can be disabled here, and
that is simply because none of the services actually calls the API gateway.
Yeah, exactly.
They simply call directly the microservices itself. But if you go to this resties, as you see, we have this load balancer parameter, and if you will leave this as it is, so the just empty string, we will use the first strategy. So we'll simply use the data hard-coded into app settings. So this is what we actually did in the previous episode. If you will change this to Consul, this will actually use this HTTP Consul client for fetching the services from the registry, and then we will use the data from the registry to actually build this host part.
And you just need a name, right? You just need a name, because this will be skipped, because it wouldn't make sense otherwise. It will just take a look into the name of the service. That's it.
Yes. The host scheme and the port is not necessary, because we will get this data from the console itself. So this is the second option. And the third strategy also involves the Fabio in this process. And we'll simply forward all requests to Fabio, and Fabio, based on the routing table, will decide using the round robin or the pseudo-random. Of course, this depends on the configuration, but this will forward this request to the particular instance of the particular type of the service. So using this key.
So if you take a look into the extensions for REST, you can see that you have this simple switch for like no load balancer at all, Consul and Fabio. And if I take a look at Fabio, you can see that it just creates a new HTTP client for Fabio, and it just adds this message handler for the Fabio, right? So it only cares about two things: it cares about the URL of the Fabio itself, and about the service name. So and then it can invoke this send async method. Okay.
Yeah. So maybe we could create this. Make it.
Let's try to run it. So I set this to be Fabio. I can remove this one, just to prove that it's not needed. Let's make it discount service, right? And what else? In my Fabio, I have this URL. I will also define the service name for my API, because I think we added this parameter to be we set it to be required. So let's just put it here. Besides, there is nothing else that we really need. Okay. So we'll try to use we'll try to get our discounts using the Fabio, right? So if I get into my discounts controller, you can see here that we are calling the rest is, and we are calling this get find async method for the customer ID. So we'll get all the discounts, and this is our service. And now the rest is should get our data through the Fabio, right?
Yes.
Okay, so app settings set, and now let's only start our discount service. So everything should be.
But
stopped.
I don't think that you actually provided the configuration for the discounts.
Yeah. That's the last step. So let's just copy this and into our discount service app settings. Let's put it maybe here, and this one. Okay, let's enable this one. URL name will be discount service, and as you can see, we also set this retries, but that's a topic for the one of the next episodes.
Yeah.
And let's start our discount service, only this one, because we'll try to get the data through our gateway. All right, so where was my discount service? It's here. So let's run this one.
Come on. Yeah. This.
Okay, let's take a look at our console. So it should be in console. And it should be also available in Fabio. So you can see there's discount service, there are these tags. And let's open the console, the Fabio routing table.
Oh, and one more thing. When it comes to Fabio, I'm not quite sure, but I think. Oh, and as you see, the weight is 100% because we have just one instance of the particular microservice. So there is pretty much no to balance.
Yeah.
Nothing to balance because we have just one.
If we run the two instances, there would be two instances available. Should we give it a try?
Yeah, we can.
Okay, let's see. So I can easily change my my port. So let's go into my properties and maybe let's make it 5011, like this, and also make this one.
But what I want to say
Yeah.
is that I think that the Fabio itself requires your console to integrate with the health checks. I think that
yes.
If you want to use the Fabio, you need to have this console configured with the health checks.
Yeah,
because otherwise this will not work.
Yeah, because the Fabio builds this routing table dynamically. So the health checks are really required. So let's see if I started my discount service once again.
But on the other port, okay?
Yeah, on the other port. One more thing I need to do. I need to fix the endpoint for the health checks to make it available on this one, right?
Yeah.
Because it will also. Okay, let's run it once again, and we should see that there should be two instances of our discount service.
Yeah, this is how you actually create.
Okay, so the console started pinging our second instance. So let's see. Here, there is 4 because we have 2 instances. Yeah.
2 health checks.
And 2 health checks. And let's take a look at Fabio. And nice, two instances with 2 weights. And remember, you also have the CLI for Fabio, and you could do some sort of sophisticated load balancing based on weight.
Yes.
You can define different ways for different services and so on. All right, so let's just try to get our discount service for the Fabio. So I can just call discounts service and localhost 99999 as base URL. Did I make a typo here? Or 1 second. Oh, I made a discount instead of discounts. I think I'm...
Okay, so never...
Yeah. Okay, it works.
Yeah.
So let's get into our API and just make sure that we have discounts. Sorry, discount, not discounts. Yeah. So let's just make a quick fix because it's a discount, not discounts. And let's start our API. And it should work. So I think I have API somewhere here. Here's compose. Okay, here's the API. .NET Run.
Right.
And yeah, let's look for a customer ID in the meantime. So let's see. Let's refresh my discounts. We don't have any discounts really, but at least we should get an empty response, right?
Yeah.
So let's copy this ID. Let me just take this GUID part. Okay. And what we can do now? We can do a local 5000 / discounts, right? And I think we need to provide this the customer ID as this parameter.
Yep.
Let's see if it's up and running. Is my API alive or not? Okay. Discounts, customer ID.
Now we have discount.
Discount, yeah, right. Discounts. Why it's discounts?
Yeah.
Discounts. Customer ID equals this one. It should talk to our, let's take a look at the logs. HTTP discounts, customer ID. So you can see it's calling this this URL. Oh, I know what's the mistake. We registered our service the console with this typo. Yeah, that's my bad. So let's.
Oh, we did a typo. Okay.
Yeah, we have this typo for the discount, not discounts. Yeah, so just make it proper discounts, and also here the discounts. So yeah, magic strings. So discounts. Yeah, here should be discounts, and now everything should be fine. So let me just restart my API and restart my discount service. Whatever the instance, I just change the port to the default ones, and it should work. Yeah, and remember, logs are the source of truth. You can see that it actually tried to get the valid endpoint because it got translated for this simple REST is Fabio integration, but it just hit the discount instead of discount. Okay, discounts. It's in use by the previous service. Where is it? API. This one. Yeah, so I just killed the previous discount service, restarted, and it will finally work. Okay. So let's see. Okay. Localhost 5000 should be up and running. Did I actually? Yeah, too much.
Yep.
And finally, our discounts once again. There is my URL. Okay, my service is up. And finally, it works. We got the empty data because we have no discounts. So as you can see, this is our discount service, and this is our API. It hits this endpoint, this endpoint through the Fabio. Fabio takes care of this routing table. It looks for the available instances and returns the data for you. So this is how you can make use of Consul, how you can make use of Fabio, and how you can use REST is in order. And finally, we would like to create a service, REST is service, to communicate with our order service, just like we did in a previous episode for API gateway and communication between API and discount service. So here is my discount service, and in the meantime, I also started all of the services that use Consul and Fabio. So if you open a Consul now, you can see that they have been registered here, and they are also available as a part of Fabio's routing table. So simply applied Fabio and Consul enable to true, and modify the app settings for each of this particular service. So the last step, new directory. Let's make it services. Okay, and now let's create a new interface. I order service. And we can basically take a look at our order service that is part of the API gateway.
Yeah, we'll copy paste this.
Exactly, and we can just take this definition and just change it to be a details DTO. Add references, and yeah, we are good to go. So the remaining thing, we have two things that we need to do: configure the REST is and register the forwarder. So here I can type again add service forwarder, register service forwarder for this order service type, and this section will be called order service. And finally, let's take a look at our app settings for the API gateway. Here is the section for the REST is. Here is our Fabio load balancer. And now let's just copy and paste this one. For example, here. And pretty much we only need this discount service. So we don't need all of the services because we'll be using only this, the order service. So we need to do the following. And we don't need this whole scheme part because it will be resolved for the console or for the Fabio, depending on the load balancer.
And this is just this is only required when you don't have any parameter in the load balancer, because then we use the default HTTP client and we need this.
Yeah, and the last step is to update our handler. So within our order completed handler, we can get rid of this console HTTP client, and let's just inject here our iOrder service. And this is going to be like our final step. We can call it level 3.1 or level 4. Simply order DTO equals await order service get async, and we'll provide here our order ID from the event. Now let's start our discount service in a debug mode, hopefully for the last time, and see what happens. Also remember that the discount service, we need to enable console here, and we also need to enable Fabio here.
Yep.
And once it starts, it should be part of this routing table as well. So let's wait. Yeah, and while it's starting, let's see if my cart is empty. Okay, so the cart should be empty. Oh, it's not empty. Okay, I have some remaining items here, so it doesn't really matter. And let's see if I have already completed all of my orders, or are there some orders that are not completed yet. So, okay, all of them are completed. I have 2 items on my cart, and I should be able to create a new order, complete an order, and this order service should be resolved, and we should hit this breakpoint here. So let's see. Okay, it's part of our Fabio, it's part of our console as well. So everything seems to be up and running. And now the final step. Let's post to the orders endpoint, which is, okay, it's here. We should get a new order. I'll get this ID. And let's just try to complete an order. Okay. Send a request, and let's wait.
Fingers crossed.
Yeah, fingers crossed. Yeah, it's getting here. So our order service has been resolved. Now F5, and let's see what happens.
And
are we going to get the data?
Yes.
Yes, there is the data. So we have the data here, and everything is valid. So maybe to sum up, because there was quite some time in this episode.
Yeah.
So what we did during the way?
Yeah. So basically, we started with the issue we got to the. So we kinda had to figure it out how to avoid. First of all, of course, we want to avoid hard-coded variables in our source code, because if you want some change, you need to recompile and redeploy your application, and that's a bad thing. So we started actually in the previous episode from the level 1 where we stored our settings in the app settings.json, but this is still not enough for us, because we wanted the services to be responsible for their registration somewhere. So we introduced the console as a server service discovery, and the console provided us this ability for services to self-registering, And using Consul, we were able to get the registry of the particular services depending on the given key or maybe the grouping key, whatever you call this. But since the Consul provides very simple load balancing, we also introduced the Fabio, and that was the level 3. And the Fabio creates this dynamic routing table and provides the load balancing using either pseudo-random or round robin. So that was the final, I would say the final step for the infrastructure, but we got this additional step, like so the level 4 or that was level 4. So basically, if you'll go to the common package, you will see in the source code that basically you can create a simple interface just for the resties, and depending on the parameter that you provide in the load balance parameter in the app setting JSON, beneath the different strategy and different infrastructure will be involved to make this HTTP call. So yeah, that's pretty much what we did. And I think that before we finish this episode, two things that I wanted to mention. First, if you'll go to the our forum, then there is a topic related to this Consul and the Fabio, and that's where you can see there was some issue, but there was also another topic where if you'll go to,
maybe was it on Gitter or this one, I think.
Yeah, so you have this three ways of configuring this synchronous connection depending on this parameter called load balancer. So that's the one thing, and the other I wanted to say is that can you go to my GitHub? Because if this seems too much for you, I think that I have this repository, very simple. So this is the default ASP.NET Core app, and to my repositories. Yeah, this is Consul Fabio demo. So you will have 3 branches on this repository, and as you see, step 1 is hard-coded endpoints. Step 2 is the Consul, and then you have the Consul plus the Fabio itself. So this is a simple ASP.NET Core app with no extension method, with just the infrastructure necessary for connecting to Fabio and Consul. So you can start with this and then move to a common package in a DShop, because maybe this will confuse you less, because this is quite a lot of code that you need to analyze and understand actually.
Yeah, and also remember about all these things related to Docker. So for example, if you would type here just a local host, then the ping probably wouldn't work, because your Docker doesn't, for the Docker, the local host is its own container. So unless you're running on Linux with a special parameter, you will not be able to ping your service. So you need to either use this host Docker internal, or then you need to use this Docker for Mac or Docker for Win localhost, because otherwise you might get into some troubles. But again, it's mostly for the local development. Once you publish your app somewhere to the cloud maybe, or on some VMs, then you probably start using here some static IPs or static DNS, so it's no longer an issue. Or you just put your microservices into the Docker, and then you just start using these aliases, these services names, and then it all works. But for such local deployment, when some of your services are local on localhost, some of the services are part of a Docker, you need to be aware of these issues.
Yeah.
And I think that's pretty much it.
Yeah.
Right?
Yep. I think that that's the longest episode so far.
No, it's for sure the longest episode so far. Okay.
So we're getting better.
Of course.
So
let's wait for
you can
3 hours.
expect that in the next 10 episodes, we'll just sit here for 4 hours and talk.
We're gonna be Lord of the Rings.
Yeah.
Director's cut. Okay, so that's it. And
we'll
see you next time.
week. Yeah.